be able to do is to understand that all matter is, well, all matter, you probably would tell me, is made up of cute little atoms. I love the atoms. But those atoms can then, matter has mass and occupies space, and matter will be classified as either being pure, and if it's pure, you have two options, okay, an element or compounds. And if it's a mixture, we're going to talk more about this. Basically, the thing about a mixture is that you've got pure substances, either elements and or compounds, that just like a tossed salad, you just throw them together. Okay, so that mixing part you can undo, just like you could take a salad and you could pick back out your lettuce and your tomato and your, okay. So then down here we said you can go back and forth between elements and compounds by chemical reaction. You can build elements up to a compound, like, take two hydrogens and an oxygen, make water. Or you could go ahead and take a compound and break it down into its elements by chemical means. All right. So again, substance. Substance and pure substance, for me, mean the same thing. Okay, it just means that you know what you got. You got a handle on it. It's a pure substance. It's a repeating unit of either one type of atom, which makes an element, or it is a repeating unit of a unit, a group of atoms, either called a molecule, or remember we talked about two different types of compounds. I introduced you to that idea. We're used to saying the formula for water is
H2O.
Perfect, H2O. The formula for table salt is, yep, NaCl. We covered that the other day.
Okay.
Yeah. So it has one
Is that something we're
sodium.
supposed to know before?
No. But table salt is another example of a compound, was my point. And you know that if you were to look closely at a little grain of salt, you'd have repeating units of NaCl, NaCl, NaCl. You just
That's
know
what
it.
forms together to make
Yeah.
salt.
Yeah, you just know it. It's a pure substance. Okay. So just to focus a little bit on mixtures before we leave. So mixtures are always just kind of physically tossed together pure substances. That's what they always are. But one of the things you probably already know about mixtures is sometimes it's really mixed really good. Okay, we call that a homogeneous mixture. Okay? And sometimes it's chunky. It's not mixed so good. And it's a heterogeneous mixture. That's just it. Okay. So the physical tossing. I like to tease that you can take, so pizza, what do you think? How many people think it's a homogeneous mixture? How many think it's a heterogeneous mixture? I'm thinking so. How could you make it more homogeneous?
By making it all the same.
Yeah, by making it all the same, like put it in the blender or something for somebody who's on a straw diet.
Yeah, there you go.
You could homogenize it, right? That is disgusting. But when you're desperate,
You're hungry, you'll take it.
So the assignment that's actually due Wednesday is a handful of questions from your textbook, and you're going to kind of say, is that a mixture, a homogeneous or heterogeneous mixture? So one of the things about a mixture where you physically toss two or more pure substances together is you get to pick. Okay, one of the things I kind of tease, our daughter's like almost 16 now, I can't believe that. But when she made Kool-Aid, okay, she'd make it very sweet. Okay, so if this is my pitcher, okay, she would dump like 1 1/2 cups of sugar.
Do you mind if I shut the door?
I'll get it. Because it's like the history of rock and roll. I'm just like, but you can't take it because you're taking this class right now.
Exactly.
Okay. So 1 1/2 cups of sugar, okay, for a given amount of water. Now, when I would make Kool-Aid, Mr. Kool-Aid over here, same amount of water. How much sugar do you put in if you make Kool-Aid?
In a gallon.
Or just like an envelope?
Like 2 cups.
Oh, good Lord.
2 cups sugar in a gallon.
2 cups of sugar. Oh, well, okay, so that's a gallon.
Yeah.
Okay.
Yeah, not in like the glass. That'd be ridiculous. It'd be
Gotcha.
syrup.
Gotcha.
Gosh.
But my point is you have a mixture, because if we were to look close, we'd have the water and sugar. Could we get them back separated again? How could we do that?
Strain it.
Strain it. If it's got like sludge down there, which sometimes it does, it's what we call saturated.
It
Yeah.
doesn't always dissolve.
Strain it. How else could we? Boil it, drive off the water, exactly. Both straining it and boiling it, those are what we call physically just. If we do either one of those, do we still have water and sugar? Yeah, that's why we know it's physical. Okay, so we can make it up how we want to. Okay. So here are some examples. Let's see, what do you think? These fall under the two categories. This yellow one, how many people think it's a homogeneous mixture? Me too. Why do we think it's homogeneous? Because the same throughout. What about this next one? How many people think, why is this heterogeneous? Yeah, because it's different. It's got some chunky, blobby stuff in it. Exactly. Do not drink either one of these. Okay, so again with mixtures, you know, if I told you this was mostly water, you'd say, well, there's something else in it to make it that pretty blue color, right? So it's a mixture. How many people think that this is homogeneous mixture? Me too. And then what is this? Heterogeneous. Why is this heterogeneous over here?
Because it's a couple different types of sand and
Yeah.
dirt mixed together.
One of the things, exactly, one of the things in my days of wanting to make sure I got a representative sample is you can use these like little sample thieves. So my point would be with the reason that kind of sand and charcoal is heterogeneous is if I were to kind of sample here versus if I were to sample here and analyze it, you know, you're going to get some different sort of, so it's not the same throughout. It's more like your pizza. So, I mean, this is just a good everyday, we don't live here, right? We don't have a beach, right, I know. But just pretend you're on the beach, you know, in the salty ocean. And this is a good example of things are more complicated than we generally think of. So the salt water is actually water with salt in it. And that saline, amount of saline would vary. That's kind of shown here. And then actually, as we're walking around this room and breathing in the air, that is also a mixture. Okay.
Oxygen and carbon dioxide.
The mixture, and actually we're going to cover this in meteorology today, most of what you're breathing in is nitrogen. Actually, it's about 80-20. So it's about 80% nitrogen, and it's only about 20% oxygen. Okay. So what do you think when you're breathing in? Is that how many people think that's a homogeneous mixture? Yeah, I think so too. So, yeah, you'll do fine. So just a little bit kind of then about a special type of homogeneous mixture called solutions. So when you think of solutions, what do you think of?
Answers.
Solutions, you think of answers, very good. Think of the juicy liquidy kind. What do you think of solutions?
Two liquids together.
Two liquids
when
together.
they're mixed together.
Mm-hmm. They may, yeah, exactly.
Solution.
Solutions actually, in the physical science definition, is we assume it has to be the same throughout. It's a homogeneous mixture. So solutions are homogeneous mixtures. There are a lot of S's when you talk about solutions. Usually, and kind of back to what was set up here, usually you have something that you have a lot of, and that's called the solvent, and you add a little bit of something else, whether that's another liquid or a solid you want to dissolve, and that's the solute. Okay, there's something in lesser amounts. And then one last thing before we end up with kind of this deviation with a special type of homogeneous mixture is if somebody says it's an aqueous solution, then basically the solvent was water. And water makes a great solvent. But are there some things that don't dissolve in water?
Yes.
Yeah, that's true. Very true. Okay, so these will be due on Wednesday. Okay, let me show you what they look like. So I've got the author's e-text out here. Okay, so these are the ones that we'll be due on Wednesday. And if we kind of take a look at them, like I said,
Snicker bar.
yeah. Now, we could go through these right quick, but you're going to do them yourself. And you don't have to use complete sentences, okay? But for each one, and remember that the odd ones, which would be 33 and 35, the answers are in the back of your book. Let me make it a little smaller so it all fits. Any questions about that?
So when it says like problems 3.33,
Mm-hmm.
just chapter 332 or 33. Oh, okay, thank you.
Thank you, yes, at the end of the book. Perfect. You're trying to help your fellow student be less confused. I appreciate that.
I'll ask stupid questions.
It's not a stupid question. Okay? Any other questions? Okay. So let's take a look at part 2, unit 1. And I just want to get a certain way into here. Basically, the first assignment slide. If you're kind of saying, well, when are we going to quit today? Well, probably the next assignment slide here. Okay. So the concept of a property is something you use all the time. A property is your ability to try to describe matter. Remember, matter can either be a pure substance or a mixture. So you're basically trying to assign a characteristic. That's a property, okay? Properties. And here in a minute, I think we got enough time, and it'll be worth 5 extra credit points. Anytime I do anything new, it's 5 extra credit points. These actually go towards missed assignment points, or if you miss an assignment. Each assignment that you're handing in is worth 10 points. Okay, it's funny, not really funny, but some assignments you hand in take a lot more time than other assignments, but they're all 10 points. Okay, so there'll be 5 extra credit points when we play the I'm thinking of game here in a minute. Okay, so properties is basically to describe something. We could say that's green. We could say something's salty. That's actually a property. We could say
Something's hard.
Yep, something's hard. Yep, something has an odor. Exactly. So now properties, I want to kind of divide up into 2 pairs. Okay, there's 2 pairs of properties, but what they have in common is basically pointing to something and describing it. A pair of properties. Pair types of properties are intensive and extensive. Okay, intensive, as many times as I've taught this and as many years ago as I learned it, I usually think of the word independent. Okay, independent. It's funny how, long time ago you learned something. And what the independent is it does not depend on what?
Amount of man present.
Yes, does not depend on amount. A lot of things that I just said a minute ago, sir.
Oh, I didn't practice stop. My book's a little bit different for some reason.
Is
My
it?
part 2 is like 3 more pages, but I have all these same notes. They just run together as the other.
Yeah, it's weird.
So,
Do you guys' match up?
No. See, I don't have part 2. I don't have the slide that says part 2 until I might already get past it. But it's a few pages after. I remember I found it.
Well, we'll have time here in a minute, and we'll kind of look at yours side by side.
Okay.
Oh, I hope I don't get a screw.
Gotta love that
Oh,
book
yeah,
stuff.
see, here's my Introduction to General Chemistry, Unit 1, Part 2, Measurements.
Unit 1, Part 2 is measurements, not,
I thought that's what weird. Yeah.
okay. Well, you're okay, because you have, I probably would be writing it on that.
On this one?
Mm-hmm.
Okay.
And it doesn't apply to you guys. I will check the bookstore, because it sounds like you have what's the front cover of your book say? Because yours says,
Introduction to General Chemistry, 2014-15.
Yeah.
same thing.
Same, I mean, these are all the same notes,
Yeah,
but that one,
notice what yours is missing.
4th edition of,
Yeah. Which I know we're in the 5th edition of Tro, but Tro didn't do much between the 4th and 5th.
all right, well,
Okay, so-
I just went and got this from the bookstore like
Okay.
5 minutes ago, so.
So
Yes,
this was
it's a-
probably the 5th then.
It's nothing that he's done, but I think at the bookstore, they will need to swap you out. So I'll keep feeding you
And we want the fourth edition then?
You want something at the bottom at least says Tro, and it will say 4th edition, but your textbook is the 5th edition, yeah. It's in my syllabus.
Is it? Okay.
The syllabus
Cool.
says 5th edition Tro. No, it doesn't. It says 4th edition Tro.
It's in fourth, but you had it change it when we went over it.
Okay, thank you.
Yep.
You are
What do you
so
want me to
good.
do for these slides, because they're
I'm
not.
like, can I put you in my pocket?
What's that?
What do you want me to do for these slides, because they're not on this piece of paper, it stops at the assignment that you gave us.
You're okay. This is just what I covered. When I gave you the syllabus, I gave you part 1 up to this.
Okay.
So where's your, did I give you? No, I didn't, because, yeah, you're the 3rd new student
Yeah.
today.
Yeah, I'm just
Okay.
lost, I'm sorry.
Okay, no, you're fine. We'll get there. And are you still thinking noon's gonna work for you to stop by?
Yeah.
Okay. All right. So those who still need to go to the bookstore, if it doesn't say Tro at the bottom of the front, say Mrs. Snipes is gonna have to come talk to you. T-R-O, that's the author. No fights. We'll get there. In the meantime, I'll keep giving.
She's gonna turn you into
keep
an
giving you the
intensive
sheets.
property.
Okay. So, independent of amount, okay? And I'll try to tell you what things are dependent on amount, actually, coming up. But examples of properties or characteristics of matter that don't depend upon how much matter you're trying to point at would be these. You know, Mountain Dew tends to have, I always think green, right? Okay. There's a Comet out right now, Comet Lovejoy, and it's that beautiful kind of Mountain Dew color. Okay, but it doesn't matter if I have 1 can or if I have like 500 cans.
They're all
Okay,
green.
they're all green. We're going to talk about some characteristics of matter, and we're very careful with this sort of matter in the lab, is they tend to be reactive, either reactive in air or reactive in water. That's a property that you need to know about. It's a characteristic. It's reactivity. Okay, it doesn't matter if you, sodium, how many people have seen sodium react with water? Okay, it doesn't matter if you have a little chunk of sodium and you're dumping it or putting it in water, or if you have a big old chunk of sodium and you're going to throw it in a stream. Okay, it's reactive. That's a property, a characteristic of sodium. Okay, so the paired with intensive, independent of amount, is actually extensive properties. So extensive are dependent. Okay, they're not independent. Okay, they're dependent. Okay, so it does depend upon amount. So an example of those I have up here. If we go back to the whole sodium thing, okay, a little bit of sodium. I have a lot of respect for sodium. We've got some in the storeroom in the chem lab. Versus a chunk. Okay, they're both reactive. That's a chemical property. But another chemical property would be how much energy is going to be released when we go ahead and react that with water. Okay, which one's going to give us more energy?
Giant chunk.
The giant chunk. Okay, so property would be the amount of energy released. Okay. So it's kind of it's a little bit of a subtle thing, but intensive and extensive. Okay, independent amount and dependent amount.
Do you have, like, how you said independent for intensive, do you have like a little thing for extensive?
Nope. I usually,
How come?
if I see extensive, yeah, I know. Like, do I have a mnemonic thing with extensive?
mnemonic device, there you
If
go.
I think of if I run into extensive, I usually pair it up with intensive, and then I say intensive is
Is
independent,
independent,
so
and
extensive is
opposite.
dependent. Yeah.
Okay.
So there's I am bad at memorizing things. So I usually sometimes I'll go back to the ground and build up, and that's one of those.
That's a good idea.
So the other two that are paired together, again, a characteristic of matter is a characteristic that's physical or a characteristic that's chemical. So we have physical property and chemical property of matter. And there's definitely overlap between intensive and extensive and physical and chemical, okay? And I think I'm gonna try to prove that to you. So physical properties, the deal is that you can, physical versus chemical. Physical means you don't have to do any chemical reaction. Physical property. Another way to think of it is physical property is just by eyeballing it. Or by running it through some test that doesn't change the substance. Okay? No new substance is formed here. I guess that's probably how I would emphasize that. Physical property. When you measure it, no new substance formed. when a lot of times, yeah, if you stay in chemistry, you might end up in one of those chemistry labs, chemical labs, where people send you a sample and they want you to run all these tests on it, right? So when they run a bunch of tests on us, get one given sample, there will be the non-destructive tests, okay? Then there will be the destructive tests, okay? To get to the analysis, okay, of what you got. So non-destructive tests would be measuring physical properties. Destructive tests, you're doing a chemical reaction and you're kind of using up your sample. Okay. These are all examples of physical properties. No, if it was an element, it stayed an element. If it was a compound, it stayed a compound. If it was a mixture, it stayed a mixture. As we measure all of these things. Okay. A lot of times, students will kind of struggle with the whole. Let's see if this will go back. These right here, okay? These temperatures, the temperature at which something boils or the temperature at which something melts, that's a characteristic of that matter, okay? Case in point, I've got right here, okay? The temperature at which something melts. So here's kind of a quick and dirty test. Somebody gave you two white substances, and I know some of you guys have taken or will take forensic science here, two white powders, which is which? They said one is aspirin, which you can take for a headache, and the other is naphthalene, which you would use to kind of drive off the moths that are bothering your coats. Okay, it's the mothballs sort of thing, naphthalene, yeah. Two white powders. And you know that one melts at 80 degrees Celsius, and one melts at 135 degrees Celsius. So what this brilliant person has done is said, what temperature does water boil at? Celsius. 100, exactly. Boils at 100. I do this because it kind of depends upon if you're in the mountains, okay, if you're at sea level, it boils at different temperatures, but 100. So put both those powders at 100 degrees Celsius. This one won't melt, right? Okay, and this one will melt. Okay, so you know which one to take for your headache. But the point here, it's in context of what we've been talking about, do you see where it's in measuring the melting point temperature? By the way, what we could have done with this is to kind of ramp up the temperature of the water bath little by little by little and look for that temperature at which it melted, which should be around 80.2. That's not how we get to melting point temperatures of solids, but we could do that. Okay, but do you see where we didn't break any? We still have naphthalene and we still have aspirin. Okay, that's just it. That's just it. Okay, so just eyeballing, we can see these pretty different colors. Color is a characteristic, color is a property, but it's a physical property. Okay. Viscosity, let's see if this